finishing off logs and exponentials, and this will be our last topic for pretty much for the term. The rest of the term we're just going to be revising. I haven't had anyone that's really had a problem with exponential and log graphs because you're going to be attempting them the same way that you would have attempted your normal functions. So let's just have a quick look at one. Exponentials. Exponential graphs are in the form of y is equal to, let's say any number to the power of x. So it could be 2 to the x, 3 to the x, e to the x, and so on. Those are all exponentials. Your basic exponential curves, the equations, we just wrote one, so y equals a to the x. Condition on a has to be pretty much a number. It's got to be a constant. So even e is a constant, just like pi is, right? These are constants. X's are your variables, so it's got to be a constant. What that means is you can't have x to the x. Right? That's complicated. So your domain, well, you guys kind of know what an exponential looks like, right? From what you've already been doing in term 1. That's your exponential function, cuts throughout 1, and then has asymptotes here at 0. So what's your domain? Isn't your domain just all real x? Now what's your range?
Above 0.
Above 0. So a different way of writing y greater than 0, you could write 0 all the way to infinity. 0 to infinity, not including 0. When x is 0, so when this power is 0, what do you get? What's anything to the power of 0? 1. So y equals to 1. What happens when x is 1? When x is 1, well, you obviously get the constant you have, so a, 2, or 3, or e. And what happens as the limit? What happens to the limit as x approaches infinity? So what happens to the function as x is getting larger? What happens to the function? So what happens to the limit as x approaches infinity for your exponentials? No one's got an idea? What's happening to the function?
X becomes larger.
It's becoming larger, so that pretty much becomes infinity. Another way to think about it is you're going to have a to the power of x when x is infinity, so a to the power of infinity. Think about it. What's a number to the power of a very, very large number? Well, it's going to be bloody big. So it's going to be infinity. And you can see that graphically here. It's approaching infinity. It's going to keep getting larger and larger. What happens as x approaches negative infinity? So this way now. Negative infinity. This was x approaching infinity. So in other words, yeah, as x approaches negative infinity, what's happening to your y value this time? It's approaching 0. So it's really, say it again, yeah?
It gets smaller.
Yeah, it gets smaller to what though? It's really important that you get it. So it gets smaller to 0 pretty much. So yeah, a to the negative infinity, it's a good one to remember because you will get asked this in an exam, I can guarantee it. A to the power of negative infinity, so a number to the power of negative infinity, it approaches 0. So you guys got to remember that one. We'll do a question soon. But anyways, otherwise, I mean, that's your normal graph. It's just an exponential function. Any questions before I move on? No, didn't think so. So here we go. Question 1. Let me see if I can make my my little pointer a little bit bigger so we can all see it because I'm having problems following it. Let's go with red. Yeah, that's a little bit better. All right. So y equals 3 to the x. Well, that's just an exponential function, right? There it is. What does it cut through? I mean, it's always good to learn to do x and y intercepts. Why not? Yeah. 3 to the 0. So when x equals 0, 3 to the 0 is 1. So y equals to 1. And then when y is 0, it'll look like this. And then how do we solve exponentials? So what do I do to both sides? Come on, I've got an exponential. What do I do to both sides to get rid of the exponential? I don't want the x on the power there. What's the opposite of an exponential?
Log.
Log. So log. What's log 0? Well, log 0, if you plug into your calculator, is undefined. You'll realize that when we do the graphs for logs, you'll realize you can't get log of zeros or negative numbers. So y will never be 0. If y is never 0, that means there's an asymptote there. See? And that's why you've got an asymptote. I'm just trying to prove it to you using what you've learned last week with logs. So if you try to actually solve it, you can't. And that's why that's going to be an asymptote. And that's it. Any questions? You know what? It's good also to plot more points. So why not? Like if I plotted x was 1, you'll say that's 3. And when x is -1, you would say that is, 3 to the power of -1, or 1/3. It's good to show that you know what you're doing, you know that you're substituting numbers and everything's working out. Easy. Any issues? y equals 3 to the -x. Anyone know what to do with that one? 3 to the -x. Come on, you got to say answers. It's good. It's good to get things wrong. Wait, you guys got to understand something. If you don't say anything, it worries me because I'm worried in an exam you'll also not say anything. You just be like, I don't know what to do. I've never seen this. It's better to get things wrong. Yeah, go ahead.
Does the exponential go down?
Exponential go down. Okay, good one. See, that is this. What you just said is that. -3 to the x.
Like it reflects on the y-axis.
Yeah, it's this one here. All it's trying to say, if you think about it, when the x's were positive, now your x's are going to become negative. And when your x's were negative, with a negative x, it will make them positive. So technically, it's actually a reflection this way. So all of these numbers came to this side, and all of these numbers went to this side. That's how I see 3 to the -x. Again, worst case scenario, I'm sure you would have subbed in some numbers. There's 1, there's -1. If you had subbed in 1, you would have got 3 to the power of -1. So I think that was you, Tiana, that said flip it down. You'd have realized you would have had positive, a third. And then if I subbed in -1, you would have had +3. You would have been like, what? There's a dot there and a dot here, but I'm thinking it should have been down here. Something's weird. Oh yeah, no, that's got to be the other way around. I've got to flip that about the y-axis. Cool? So it's good getting things wrong because you can learn from that. Tiana, makes sense now?
Yeah.
Beautiful. And no dramas, like test points, it's actually a good thing to do. All right, next one. Y equals 10 to the x. Again, same thing. When x is 0, 10 to the 0 I know is 1. That's the first thing I'm looking for. And then if I sub in 1, I know I get 10 to the 1, which is 10. If I sub in -1, I know I get 10 to the -1, which is 1 on 10. And pretty much I know, oh yeah, it's just in my normal exponential because this hasn't moved anywhere. Oh. And then obviously you have your asymptotes there. And there. These asymptotes haven't moved just yet. All right, any questions up to this stage? Some of you might realize, hey, well, this is exactly the same as what we just did in term 1. And it's meant to be like that. That's the whole point of the new syllabus. They've tried to make term 1 a very crucial term to learn everything, and then pretty much the rest of the terms are just recaps of a lot of the things you've already learned. Next one, y equals 1/6 to the power of x. So y equals to 1 on 6 to the x. Okay, what's the first thing I'm going to sub in? X equals
0.
0. And then I get anything to the power of 0 is 1. What's the next thing you will sub in, Eden?
0.
After 0, you've already subbed in x is 0.
1.
You'll sub in 1. And when you sub in 1, you get 1 on 6, which is down here. So there it is. And then what's the next number you would sub in? Negative 1. I'm usually subbing in 1 and negative 1. They're just the best two to sub in. You get positives, you get negatives. What's 1 on 6 to the power of negative 1? Plug it into your calculator. What do you get? You get 6?
Yeah.
So you might have thought, oh, that's just going to be my normal exponential, but this guy's telling you it's actually this way. And there you go. There's the answer. Really bad graph, but I think you guys get it. There's your asymptote, there's your exponential. Cool. Plotted 3 points, I pretty much knew exactly what was happening. Question 5. Y equals 2 to the x minus 1. All right, maybe Lisa, tell me what's the first number you would sub in?
0.
0, so what do you get?
0.
When x
1.
equals 0. Take your time. When x equals 0,
Negative 1.
you get minus 1, so what's your answer? What was y equal to?
Negative 2.
Ooh, close. 2 to the power of negative 1.
Okay.
Right? So that's 0, take away 1 is negative 1, and then 2 to the power of negative 1, which is a half. That's saying it's a half now there. All right, what's the next number you would sub in?
1.
1, so x equals 1, what happens? Just be careful now. Y equals,
1 minus 1.
which is 2 to the power of
0.
0 equals
1.
1. All right, so at 1, it is 1. And then at negative 1,
8.
you get minus 1, which is negative 2, and that becomes a quarter when you plug that into your calculator. Just from me drawing that, do you think you know the answer?
Yep.
Has it shifted up or down at all?
No.
No, these ones are shifts up and down. So your asymptote hasn't moved yet. So it's still there, and you get the idea. And there's your asymptote. You happy with that?
Mm-hmm.
All I'm doing is just substituting numbers that you were doing back in like year 7, year 8, right? You did by a table of values. We're doing the exact same technique. Instead of drawing you a table, I'm just telling you guys starting negative 1, 0, and 1 for your exponentials. Pretty much tells you your graph. Except when you're moving up and down, you follow what you learned in your parabolas. So, who wants to try number 6? One of the boys. Let's try number 6 now. Come on. All right then. Lissandro, let's start. You'll do the first one. 2 to the power of x, take away 1. Do you think you know how to graph that just off the bat?
Yeah.
What is it? An
It's
exponential?
normal exponential, but shifted down 1.
It's shifted down 1. So what's your asymptote going to be at?
Negative 1.
Your asymptote is at negative 1. You are right. And where will it cut through?
0.
Yes, because usually it cuts through at 1, but you're going to bring that 1 down to 0. Good job. And just a normal exponential, like you said. If you didn't know that, that happened for any reason, again, you would sub in x equals 0. you get 2 to the power of 0, which is 1. 1 minus 1 equals 0. So you know when x is 0, y is 0. Then you would have subbed in 1, you would have got a value up here. You would have subbed in negative 1. It would have given you negative half. So at negative 1, you would have got negative half. At positive 1, you would have got 1. And then obviously, I hope you would have drawn it like that. And then the only thing you would have had to actually know was the asymptote had to actually shift down 1. Good job. Any questions? Last one. Y equals 1 minus 2 power of negative x. Okay. Rad. You good to do this one?
Hey?
Are you alright to start with me with this one? Do you know, just by looking at it, what to do?
Well, when you sub in the numbers,
Other than subbing in numbers, by just looking at it, I'm saying.
well, you know it's going to be up 1.
It's going to be up 1. Good job. Yep. And what do you know about 2 to the power of negative x, at least? Let's say that bit.
Yeah,
What do
and
you know
it's going to swap around.
Swap about x or y.
Around Y.
Around y, correct. And then what does this negative do?
Oh, what does that negative do?
What
That
does that
flips
mean?
it.
Yes, see? So you pretty much know the answer without subbing in numbers. Look, subbing in numbers is just it's a fail-safe method. I have to teach that because I want to know that no matter what question you guys get, you're going to draw me the graph and you're going to get full marks. But as you get stronger and stronger, I mean, you got to know that guy there is going to look like this question too. Then you put a negative in front of it where you're going to flip it down. Then you're going to shift it up 1. We're just going to take the whole thing up 1. So, what's your asymptote? Rad.
Yeah, sorry, my mic was muted. So what was the question?
What would be your asymptote?
What would be the asymptote? 1.
Yes, at 1. Because you're going to shift it up 1 when it's concave down.
Yeah.
And then, what's it going to cut through?
What's it going to cut through?
Yes. It's going to cut through here, it's going to cut through there, here, 0.
Cut through.
Awkward. No idea?
No idea, no.
That's okay. Let's cross this out and let's observe what happens. So 2 to the negative x, you said it looks like this. Do you agree?
Yeah.
And it cuts at?
1.
And this is? 0.
Oh, 0. Yeah.
Cool. No, that's okay. And then when you flip this down, so that's 2 negative x. When you flip it down, you get this. What number is this now?
Negative 1.
Negative 1, and this is still 0. But this now is negative 2 negative x. Now what are you going to do to all of this graph? When you're going to plus 1 here, what are you going to do to the whole graph?
Oh, when you plus it up, we're going to move it up 1.
Where is it going to cut now?
0.
And where is this asymptote going to go?
Up 1.
Yeah, so it's going to look like this. Let's get rid of all this now. You see it now?
That's it.
So that is your asymptote at 1. That graph that we had down here is going to shift up and cut out. Cut at 0. I don't know what just happened. And cut at 0. There it is. If you, for any reason, didn't know that, that's when you can go and sub in. Why not? There's no issues with that. When x is 0, you would get y equals 1 minus 2 to the power of negative 0, which is 0. 2 to 0 is 1. 1 take away 1 is 0. So you would have realized it would have been 0 by just doing simple substitutions. You know, and you would have subbed in x is 1. You would have got a number somewhere here. You would have subbed in x equals negative 1. You would have got a number somewhere down here. And then you needed to know that there's an asymptote at 1. Otherwise, some students who just do it via the subbing in numbers, they would have got this, they would have got this, and they would have got this, and then they would have drawn this. Obviously, that's wrong. Right? So you do need to know that there was the asymptote that's been shifted up 1, which I hope by now you guys know, because you need that for even questions like this. That's a sad parabola, shifted up 1. So you got to know that. That's all of exponential graphs. Any questions before I move on? No, they're pretty straightforward. So when you do them at school, you see how simple they can be. If anyone makes it any harder, you just go back to this and you'll be like, yep, easy. Shouldn't be too hard. That's extension 1. Don't need that. That's extension 1, not for you guys. Okay. Log graphs. Well, logs are the exact opposite of exponentials, right? So logs, the inverse of a log would be an exponential. Log graphs can be log of anything, like log anything here and anything here and any power here. The domain would be the opposite of your exponential. So your exponential domain was all real x and all real x for your exponentials. I just want to show you something. And your range was y is greater than 0. Your domain is x is greater than 0. And your range is all real y. So can we see that? It's exact opposite. Domain is x greater than 0. Range is all real y. And then when x equals 1, so when you've got log of 1, it equals to 0. Sorry, equals to 0. When you've got x equals to a, if these two are both a's, then we realized from last week, you get log of a. This is not really that helpful. And same thing, when x approaches infinity, y approaches infinity. When x is approaching 0, y approaches negative infinity. And you'll just see that from the graph. So watch this. This is the log graph. There it is. What do you think this number is going to be? X equals 1. The reason why that happens is because logs is the exact inverse of an exponential. So can you see this one here, which is, I'm just going to call it ln x, and this is y equals e of x. So can you see if I had a line somewhere here, and if I mirrored this exponential to this right-hand side, I would actually get the log. And that's what I mean by they're inverses of each other. So when this is y equals to 1, this one, x is 1. You can see from the log graph, as x is approaching infinity, your y value is approaching infinity. As x approaches negative infinity, no, x can't approach negative infinity. X is approaching 0 only. As x approaches 0, your y value approaches negative infinity. Can we see that? As x is approaching closer and closer to 0, your y is getting larger and larger, more negative. And that's why you can't log zeros, right? It never gets to 0. And that's why you can't log negative numbers. These don't work because it never crosses to go to the left-hand side, unless obviously it's been shifted. That's a different case. But these all don't work, and you can see why now. And that's why the domain must be x is greater than 0. See how my domain is greater than 0? And that's why my range is all real y. Everything works for y values. All right, the log curve. Obviously, a lot of students do see it as like I guess some sort of butterfly effect. You know, that symmetry property to exponentials. So just flipping that about this line, you'll get your log curve. All right. Any questions? Let's do it. Your subbases here, if we remember from what we learned last week, f of x is, to draw this, it's just drawing ln 2x on ln 10, right? Now, log 10, what you guys got to start to learn is just a constant. So log 10, if you plug it into your calculator, give me a second, let me do it. I just want to show you to you. Log 10, ln 10, all right, 2.3. Cool, blah, blah, blah. Now, that's the same as me saying, hey, go ahead and draw x squared compared to x squared on 10. Well, they're both the same graphs. That's a parabola. That's a parabola. There has been no shifts. right? Dividing by 10 or multiplying by 10 doesn't do anything, other than dividing by 10 makes it look wider. But no one's going to draw a parabola like that, unless obviously it's a computer. So to you, dividing by 10 doesn't really do anything. So dividing by log 10, which means divided by 2.3, doesn't really do anything to your log. So just be aware of that. Don't let the sub-bases confuse you. Okay. So ln2x on ln10. I guess the best thing is, you know, I like to show you guys do your x and y intercepts. It's good to get used to that. When x equals 0, you get 2 times 0 log of 0. X cannot equal to 0, right? So that's an asymptote. To work out what your asymptotes are for your logs, you'll just make the inside here equal to 0. And that would be your asymptote, right? Because you can't equal to 0. So straight away you'll just go, oh yeah, that bit cannot equal to 0. Then, I mean, you can make the y value equal to 0. Making it more complicated than it needs to be, just to prove everything to you guys. 0 times log 10 is just 0. How do I get rid of the log? What do I do to both sides? Come on, someone just say it. How do I get rid of the logs?
Exponential.
Exponential. Can you tell me what a log and an exponential cancel out? What's an e to the power of 0?
0.
Nope.
1.
1 equals 2x. What does x equal to?
Half.
And then that's a half, and then you just draw your log. That's it. So a little bit of solving required here. Let's try another one. Let's do it together, I guess, just to make sure. Like, I'll do another one myself, and then maybe I'll pick someone up. Okay, number 2. Log 5x squared. Y equals ln x squared on ln 5. Okay, anyone have any idea of what my next one would be? Well, I'm usually thinking of x and y intercepts, yeah? What do you think?
Make x equal 0.
Make x equals 0, and then what happens when you make x equals 0? What's log of 0? Undefined. Try it on your calculator. Actually put log of 0 so you can see. Math error. Look at it from the original graph. Will you ever be able to get to 0? No. What about negative numbers? No, so you can't log 0 or negative numbers. So the first thing you're trying to do, it's more than just let x equal 0. You're trying to actually make this bit equal to 0. So the log of the thing equal to 0, because that's not allowed. That's like a critical value. So that is 0. And then from there, I mean, you'll make y equal to 0, which is allowed. Whereas for your exponential, is the other way around. You'll let x equal 0 and not the y value, because it doesn't cut through. But let's go. When this is 0, you know, I'll do it up here, question 2. You get 0 equals log x squared. Well, you know you can bring the 2 down from your log laws from last week. Divided by log 5, and then when you're going to multiply it, it's just going to be 0. Divide it by 2, it's still 0. And as you exponential both sides, that just gets me 1. So x equals 1, and then what's my graph? So do another one, log 3x take away 6. 3x take away 6. You're realizing these denominators don't do nothing, right? These log 6s. Because by the time you're going to multiply by 0, it doesn't do much. But anyways, it's good to get used to your math. your equations like that. Okay. Step 1, make the angle, so make this log of thing equal to 0, because that is where you can't have a value, because you can't log 0. So anyone tell me what I'm going to write as my step 1? What equals 0?
We put x equals 0.
But if I put x equals 0, look what happens. 3 times 0 is 0. 0 take away 6 is negative 6. You're going to get log of negative 6, which, so therefore straight away you already know it can't be 0.
Yeah.
Which is fine. I mean, now you know it doesn't cut through 0, approach 0, but still that's not fully correct, because this has moved. Clearly, 3x take away 6, you guys know there's been some movements left and right, right? But still, it's more about working out where this bit, this actual bit, is 0. So
Would it be at 6?
Say it again.
Would it be at 6?
I think you're saying it right. You mean where 3x is 6. So 3x take away 6 is 0. So therefore, when x is at 2, when x is 2, there's a problem. What's the problem?
Oh, because then your log is 0.
6. Yeah, then you're going to get log of 0, which is a problem.
Yeah.
So the fact that it shifted 2 to the right, and then that's going to become an asymptote. And then you'll do what you got to do, which is y equals 0. So the y can equal to 0. See, for your exponentials, I'll finish this one off. So when y is 0, step 2. Y equals 0. So it'll look like this. 0 equals log 3x take away 6 on log 6. Then obviously you times it, doesn't do nothing. You exponential. E of 0 is 1. 3x take away 6, and I think you guys know what to do from there. Plus the 6 and divide by 3. So your intercept is at 7/3, or what's that? 2 1/3. And then there's your log graph. What you guys got to start realizing is that for logs, you can't have x equals 0. So therefore, you're not going to be looking at when x equals 0. For your exponentials, these ones that we were doing, it's all about x equals 0, because y cannot equal to 0, right? You have that already as an asymptote. So for exponentials, it's all about x equals 0. For logs, it's all about the angle equal to 0. So we're going to call it the base. In this case, it's easy to say that. Base equal to 0 and y equal to 0, not x equal to 0. So we want the bases equal to 0 and the y equals 0. All right, so again, look at it. So I solved for the base, 3x take away 6. It gave me x equals 2, which is a problem because you can't log a 0. And then I found my asymptote, and then obviously I just subbed in y equals 0 to find my x-intercept. All right, let's try. There's only 3 more left, and that's it. That's your log graph done. Let's see. Question 4. Question 4 is log 2x plus 3. So y equals to ln 2x plus 3 on ln 7. Okay, step 1. What do I write?
2x plus 3. Sorry, Lisa.
Sorry.
Okay, wait, 2x plus 3 and then what?
Equals 0.
Equals 0, and then x equals negative 1.5, so negative 3/2. So now we know if it's negative 3/2 or any number before negative 3/2, it's going to be a problem. So it's not going to be on the left hand side. Then I do my y equals to 0. I know when I times it by log 7, I can get rid of it, so I'm just not going to write it. Exponential both sides. E to 0 is 1. 1 take away 3 is -2. Therefore, x equals -1. There's your intercept. But you can clearly see with this one, and only with this one, because obviously it is cutting the y-intercept, you can let x equal to 0. Right? And watch. What happens when I let x equal 0? What's 2 times 0? When x equals 0, you get 2 times 0, which is 0. 0 plus 3 is 3. So you get log 3 on log 7. And it worked. So there is a y-intercept only in this case, because obviously it's been shifted to the left. Shifted to the left, it'll cut through the y-axis. Shifted to the right, it will not have a y-axis, and all your normal ones will not have any y-intercepts either. Okay. Now, log of absolute value of x, that is not for you guys, that's for extension students, so we're going to skip that one. But log of negative x is for you guys. So question 6, the only thing you got to do with log of negative x, anyone have any ideas? The asymptote's still there. Log of negative x. Think of your exponentials. What happened when you made it into a negative x? So what did you do when you did 2 negative x?
You reflect over the y-axis.
Beautiful. That is exactly right. So it's going to be a reflection about the y-axis that actually looks like this. Instead of your normal ones that look like that, it's the other way around. It's this way. And everything else stays the same because I can just say it's just log of negative x. The 7 doesn't matter. You can have 7, 8, 9, 10, 20. Does not matter. Obviously, as you do, I reckon if you do your textbook questions on these, you'll become a pro. You don't need, these are exam questions. They don't get any easier or any harder. So just your basic textbook questions for these, perfect. You'll pretty much know how to graph these. All right, this one's harder. Yep, log root x, that's all extension 1. Yeah, that's all log x, absolute value is extension 1, extension 1. I think we are done. Yep. So log graphs, that's pretty much all you need to know for your log graphs. Told you it's not going to be that hard. We'll do some applications of of this. Yeah, that's not the trick. Yes, there will be a more in-depth study of later on with calculus. So, yep. So we've finished calculus. You've got to learn pretty much differentiation of exponentials and logs, but that's going to come up next term. So that's not really part of the year 11 course, more part of the year 12 course. But so we're going to just leave it there. We'll come back to it when we need to after this term. But here we go. These are all, I think, HSC questions. I don't think we bothered getting anything else. We just compiled them through HSC papers. And they're all the application questions you'll see. So here we go. Let's start with the first one, I guess. This is 2002 HSC question 9. Question 9 is the second last question. So question 9 is usually definitely band 6 students only. Band 6 meaning those above the 90%. Yeah, that's it, just band 6 students. Question 10 are those that are above 95. So there's a difference between the two kind of questions. Above 95, and then the last bit of question 10, just so you start to learn how these work, are the greater than 99. So the last bit of question 10, you might be only worth 1 mark, but it will probably require half a page or a full page of working out. So it's good to get used to what the questions are so you know how difficult they are and everything like that. But anyways, with slight modifications, obviously. we've modified them just to make sure you guys at year 11 level can answer them. So sketch y equals log x. It was worth 2 marks. How easy? 1 mark for the asymptote, 1 mark for the graph, and having your 1 there. Any questions? Easy. Double I. On the same sketch, find graphically the number of solutions of the equation log x minus x equals -2. See, and that's what I'm talking about in terms of like just guessing and getting things wrong. If you don't do that with me, then you'll get a question like this and you won't know where to even start because you're not used to guessing for yourself. So just tell me a bunch of things you want me to do. On the same sketch, find graphically the number of solutions. Log x, which is there, and then minus x equals -2. What do you want me to do? You can't solve it algebraically, so it's saying to do it graphically. You'll need something else. Come on, give me some ideas of what you're thinking. Anything's better than nothing.
We need a y-intercept.
We'll need a y-intercept of what? Any ideas of what of a y-intercept of what? No. I'll modify what you said. I think what you need is you need another graph. So you're on the right track. You know it had something to do with intercepts or whatever. It's got to cut through, but you need another graph. What would that other graph be? Come on, think about it. It's somewhere here. What would the other graph be? Give me a guess.
An exponential graph, maybe?
No, it's going to be here. It's literally going to be here. Because the idea is, Rad, you've got ln x, so you've got log x, there it is. You've got your log. And then you want to, okay, wait, let's get something clear. Maybe you guys just don't know this. Does this look familiar? What topic is this?
Yes.
What is it?
Algebra.
Yeah. And what do you do with this? What's the technique, or what are you meant to usually do with something like that?
Simultaneous or substitution method.
Beautiful. Good. So you understand this is solving simultaneously, right?
Mm-hmm.
Now, another way to see it, other than, no, sorry, when you did solve the simultaneously, what did you find? What was your x value and what was your y value? Give me a number. Seriously, give me a number for x.
1, 3.
Okay. What does this even mean when you found this? What does it even mean?
Intercepts on a graph.
Oh, beautiful. That's it. See? Intercepts on a graph. See? Eden, you get that. That's great. So it's pretty much what she can see is that when I have been getting a question like this and a question like this, and it's solving simultaneously, yes, you're doing all the algebra, and you found x is 1 and y is 3. That's great. But technically what you're finding is, well, that's graph 1. That's graph 2. There's graph 1. There's graph 2. And then wherever they intercept, it becomes at 1 and 3. You guys get that? So when you're actually solving simultaneously, you are finding their point of intersection. That's another word. That all means the same thing. Point of intersection, intercepts on a graph, solving simultaneously. All of them are linked. They're all the same stuff, just done in different ways. This is algebra. This is graphically, of course, point of intersection. So, and then obviously in this case, I would say, okay, how many solutions do you have? You would say, okay, only one solution because they only meet one time. I only had one x and one y value, so 1 point. 1 point, one solution. Okay. Anybody not get what I just said with all that? Right. We can keep the rest of that. What's happening? Come on. So for our question here, now I'm going to go back again. I've already drawn. It says on the same sketch, find graphically. So we need to find just the number of solutions. It doesn't say to find the solutions, just how many solutions we'll have. So that means you need another graph. So that when you draw the other graph on the same sketch, you can actually realize how many solutions it has. What is the other graph? So one graph is this. Y equals ln x, or log x, log ex. What is the other graph?
Log x minus x equals -2.
It's going to start with y.
Oh, I don't know.
Take a guess. It can't be log x. That's my clue. Because log x is already one of them. So what's it going to be?
Negative x equals -2.
Doesn't this look really weird to you? Y equals negative x equals -2?
Yeah.
Yep, good. You're close. You're looking at the right numbers. You don't know what you're meant to do with it. Log x, you already have that.
Mm-hmm.
Oh, come on, this guy here. X, you've got to bring this negative x over to the right hand side. X minus 2, because what you're drawing is ln x, or what you're solving for is ln x equals x take away 2.
All right.
When the y's are equal, you write ln x equals x take away 2, then you would subtract your x over to the left hand side. Right, that's what they've done. Okay, now I'm going to pause. You guys get how I got these two? There has to be someone that's confused. But you guys can't all get that. ln x and y equals x take away 2. Do you understand why I've written y and y there? Yes? You guys can see that when I solve these two simultaneously, I will get ln x take away x equals -2. Okay, well then, x is, when x is 0, y is -2. When y is 0, x is +2. How many solutions will you get? The number of solutions of the equation equals? One solution, right? Right there. This one goes on for infinity. This one goes on for infinity, but you gotta understand this log graph. Oh, would plateau. Now this log graph would be a lot faster. Oh, wait, hold on. ln9999. Actually, no, there is two solutions. I was worried about that. This log graph actually is not like an exponential that shoots up faster. So as this log graph goes this way, this guy's going to keep going higher. Eventually, these two will meet at two solutions, not one solution. Two. So if you want to test that, I just subbed in 9,999. Log that. If you log 9,999, you will get only 9.2. But for this function here, when you sub in 9,999 take away 2, you're at 9,997. So you're all the way up here. So they're definitely going to intercept twice, two solutions. All right, let's have a look at another exam question then. 1990 to HSC question 7. So this is average band 5 students. So those who are getting in the 80s should be able to answer this. A quantity Q of radium at time t in years given by this, where K is a constant and Q naught is the initial amount of radium at time t equals 0. A whole lot of words. The most important thing is just this. There's your equation. It's saying K is a constant and Q naught is the initial amount of radium when time is 0. I. Given that Q is half of Q naught, Q is equal to half Q naught. When T is 1690, find the value of K. Okay, here it is. Q is half Q naught and T is 1690. Let's try to see if we can find K. All right, what's the first thing I get rid of? I'm trying to solve for K. What's the first thing I get rid of here? This Q naught. How?
Log.
No, no. Log is when you're going to get to the exponential stage. Just Q, just a number here. Imagine a number. How do I get rid of it?
Divide.
Divide. Good job. Divide Q on this side. What happens?
Goes away.
Gone. You're not meant to have Q's because when you want to log, you don't want Q's if you're going to find the value of K. And that will happen every single question. Half equals E negative 1690K. Remember, I'm trying to solve for K. What do I do to both sides?
Log.
Now we log. Log of half is just log of half. You can't do anything to that. Log of E, we know what we can do with powers. Bring the powers down. And then you still have log E, but what does log E equal to? You guys remember? What happens to log E?
It cancels.
Cancel, but do you actually know the number of log E?
No.
1. If they cancel, it just becomes 1. It doesn't become 0. Be careful. Anything that cancels, 6 over 6, when it cancels, the answer is not 0. That's wrong. 1. Just be aware of that. Anything that cancels, it's 1. Good job anyways. And then, Lisa, I want to solve for K. How do I get rid of negative 1690?
Divide.
So divide, I'll just do it in the next line. So when you guys are writing it. Divide negative 1690. All right, go ahead, let's get an answer. Divided by negative 1690. All right, any questions? I can guarantee 100% will be in your HSC and will be in your prelims. So I haven't said that much with everything else, but this one here, 100% in your HSC and in your prelims. Cool. Double A, after how many years does only 20% of the initial amount of radium remain? So what does Q equal to? When it's saying 20% of the initial amount. What does the initial amount stand for? Come on, what does Q equal to?
Mm.
20% of the initial. Q equals 20% of the initial. Q is the initial amount, just how much radium there was when time was 0. And then it says after how many years? So this time we're trying to find T. So 20%, Q naught equals Q naught E negative. We know what K is. I'm not going to sub in this whole K, that's just ugly to sub in. We'll just leave it as k, but you already know, and k is a constant, so it never changes once you find it. All right, what's the first thing I do?
Get rid of Q.
Then 20%, I like to change that to like 1 over 5 or like 0.2. It's just easier to work with. And then what do you do to both sides?
Divide
Say it
by
again.
remove.
Divide by?
Log.
Nah,
Is
you
it?
can't, no, you can't divide by log. So there's no logs here to divide by. What do you want to do to both sides? Log it.
Don't you log both sides?
Yeah, you log both sides. You don't divide by the log. You got to log both sides. So log both sides, then you're left with log of 0.2. Log of e cancels, this comes down, so it becomes negative kt. And then you're trying to solve for t. Remember, after how many years? Trying to solve for t. What is t equal to? Log 0.2 divided by negative k. K is? And get an answer. I just used my answer key and I left this k as it is in my calculator, and I got 3924. If you didn't get that, you probably used this number. Let's just see if you did use this number. Does it make a difference? Yeah, actually, because you would round up to 3925. So if you use this answer, you would have got 3925 years, which would be wrong. It should be 3924 years. So what I did is I didn't use this answer, I used the whole value of k that I would have found here. So you write this, but you use the unrounded answer. Right? We should know that by now. Don't use, you write your rounded answer, you don't use your rounded answer in following questions. Okay. Any questions about that? Yeah, try it on your own now. 1992, 2-unit question 4. 10 kilograms of sugar is placed in a container of water and begins to dissolve after T, blah, 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 where E is blah, blah, blah. Calculate K. So again, you got to find K, always. You always got to find K first. Given that A is 3.2 and T is 4. So I'll give you a minute or two. Just go and sub in A is 3.2, T is 4, try to solve for K. Try to start solving for K. Anyone got a value for K?
Kinda.
What'd you
Is
get?
it
Yeah.
0.28485?
That's good enough. Anyone confirm or disagree?
I'm putting it in the calculator.
Putting it in the calculator? That was you, wasn't it, Lisa?
Yeah.
All right, yep, Lisa. Anyone else?
I got 0.28485.
Yeah, nice. So Lisa, Eden, looks like. Unless you both did the same mistake somehow. Looks like that could be the answer. Anyone else confirm or disagree or not sure? So do I need to do it or? Tiana, Josh, Brad, what do we think? Do I need to do it?
I haven't gotten it yet.
Okay, waiting. Yep.
I got negative 0.08.
Negative 0.08. Rad. Okay, yep. Anybody else confirm with Rad? Disagree? I'll wait a little bit longer. Let Tiana finish. Josh, Lissandra,
Yeah, I don't know how to do it.
at all? Like, what's your first line? Then I'll do it together with you. Hold on.
I think I-
Josh. Wait, Josh.
Yeah, so I'm not sure either.
Not sure. Lissandra.
Yeah, not really, no.
No. All right. Tiana. Step 1. What would you do?
So I would log it, log both sides.
No,
No.
can't work yet. The only time you can log both sides is if it's an exponential on its own.
Okay.
Like,
Would I
you
take the
can't have a
10 to the
number-
other
The
side?
idea, yeah, you can't have monic. Like, they have to be monics. That's a really important thing to remember. Like, even with your, oh, come on, even with your logs, like if it was 2 log x, you can't have the 2 in front. We said we've got to bring the 2 to the power. Right? Is Skype still working? Can you hear me?
Yeah.
Okay, yeah.
Yeah. So it has to be monic. I mean, that's the thing you want to remember. So you can't have it like this. It's got to be like this. Same thing. You just said it. What do I do with this 10 then?
Take it to the other side.
How?
Divide 3.2 by 10.
So 3.2
Would that
divided.
work?
Yeah, of course. 3.2 divided by 10 is 0.32.
Then that leaves us with an individual
And then
exponential.
what do you
Now
do?
would you log it? Both
Yeah.
sides?
And you know what, actually, you know what, if forget the monic even, imagine you had this for a second. Imagine you had 1 equals 2x squared. All right, what's the first thing you get rid of? The 2 or the power?
2.
Yeah, right, you got to get rid of the 2 first before you get rid of the power. So you have to go half equals x squared, then you go, okay, yeah, I got to get rid of the power now. So root both sides. Same thing. You can't have a number in front. You've got to actually divide it by 10 first. Then you're up to the exponential stage and you're like, well, now I've got to get rid of an exponential. And that's when you would say, oh, you log both sides. So it's exactly the same thinking as this, now that I've realized. So same thing. Yep, log both sides.
No, I forgot to log both sides. I only logged the right one.
Uh-huh. That's okay. There it is. And then, Tiana?
And then you would divide, then the exponential, sorry, ln e becomes 1.
Yeah,
So
yeah,
you
that's
just take negative 4 to the other side, divide
Done.
it,
done.
and
Yeah.
it gives you 0.284 and the rest.
So then you go log 0.32 divided by negative 4 gives you 0.284 and the rest. Too good.
All right. Thanks, Sim.
You're welcome. Good job. Well, just your first step, it looks like you're getting wrong. So that's good. All right. Double I. Double I says, after how many hours does 1 kilogram of sugar remain undissolved? So where do I put the 1 kilogram of sugar remain undissolved? Where does 1 go?
A.
A, so 1 equals 10e negative k, which you already know what it is. That's a constant, doesn't change. t, and that's what you want to find after how many hours, and that's the only variable you've got. All right, Josh, let's try to solve for t. What's the first thing you get rid of?
The 10.
10. 1 over 10, which is 0.1. I like to use decimals here because it just looks a little bit easier. Here it is. Then, what do you do to both sides?
Yeah, I log them. Log both sides.
What would you be left with here?
Uh,
If you've logged it, and you've logged it, what are you technically left with only?
just
Negative
yeah, negative K. Yeah.
KT. And then?
You. Oh, yeah. And then over
Over
K.
negative.
Negative K, yeah. Whoops, my bad.
So negative K, which is 0.2848, blah, blah, blah. Now, again, because on my calculator, I've still got K in, so it's 0.28485855708. All I'm going to do is go log 0.1, close bracket, divided by answer. So you write this, oh, sorry, negative answer. So you write this, but you use your full K value. And I got T is 8.0832, blah, blah. So after how many hours does 1? After 8 hours. Or after 8.08 hours, whatever you want, right? Cool. Copy that down. Let me know if you've got any questions, and we'll just do that. We'll do it again. All right. Same thing. I'll leave that for you guys to try. We should do that one. It's a good bit harder. That one's easy. Yeah, let's do that one. That's very more relevant. And look, question 10. So they're trying to say, I don't know, really hard. But if you keep going the way I want you guys to go, which is you're in year 11 and you're already doing, HSC questions, you'll find this easy. You'll find year 11 a bit of a year to just adjust until you learn yourself and how you study. But then by the time you guys come into year 12, you'll just be like, wow, everything's a lot easier. Just push through. Year 11 is meant to be hard. It's a harder year. All right. Lissandra, we're going to do this. We'll do I, and we'll do I together, Lissandra, so this shouldn't be too hard.
All right.
I think I is actually too easy. We're going to do I and double I. But let's read. The intent measured in watt per square meters of a sound is given by this. I equals 10 to the power negative 12 times E 0.1 L, where L is the loudness of the sound in decibels. Don't let the words get you. Don't worry. Who cares? Cool?
Yeah.
They never read too into these. You're in advanced math. You're not in standard math. In standard math, yes, you've got to read into it because they trick you through their wordings. In advanced math, it's all about the calculus, so no one really cares about the words. There it is. There's your equation. If the loudness of sound at a concert is 110 decibels, find the intensity of the sound. Give your answer in scientific notation. I. What letter is this? I or L?
L.
L. And what are you trying to find?
I.
So you're going to write I equals
10 to the power of negative 12 times E to the power of 0.1 times 110.
Yep. And that's it. And what would you do?
Get rid of the 10.
Oh, no, you're not going to, because you're not even going to solve for, you're not solving, are you? This is already all on one side.
Oh, okay.
I is already the subject. So what are you going to do?
Log everything.
No. You're overcomplicating it. Only worth 1 mark, and it just says give your answer in that word right there. What do you think you're going to do?
Oh, just
Already-
put in your calculator.
Yeah, just
Okay.
put it in your calculator. But it's already the subject. Let's get that clear. You've already solved for I.
Yep.
So there is no need to solve for it. So plug all of that in to your calculator. 10 to the power of 12 times E. Do you know how to put E into your calculator? Shift length. 0.1 times 110.
Wait, so what was that to get you? Because you cut out for me.
You press Shift and LN. So
Oh,
look
yeah.
at your LN button. On top of it, it's E in a little
Ah.
power.
Thank you, Sam.
So you should get a whole bunch of zeros and then 5987. Is that what you got?
I'm still putting it in.
Yep. Let me know when you got it in. I'll just get the answer out. 1, 2, 3, 4, 5, 6, 7, 8.
I got 0.1234 zeros, 5987.
Yeah, so therefore it should be 5.987 times 10 to the power of negative 8. So you start
Okay.
from here and then you count. So that would be 1, and you said 7 zeros. So 1 plus 7 zeros is negative 8.
Yep.
Double I. You're still going to do double I.
All right.
E damage occurs if the intensity of a sound is greater than 8.1 times 10 to the power of negative 9. What is the maximum loudness of a sound so that no E damage occurs? What letter are you solving for now?
L.
L. So what are you going to write?
8.1
Ah, good stuff. Times
times 10 to the power of negative 9.
equals
10 to the power of negative 12.
times.
E to the power of 0.1. L.
This was your K. K's already been found, just if you're
Yeah.
curious. So you're not finding K in this question. All right, good. What's the first thing? See, now look. Now you're solving for L and you do everything you were saying before.
Mm.
All right, what are you going to do first?
Now you get rid of the 10.
10 to the negative 12. So get rid of that. Divide 10 negative 12. Plug that into your calculator. It'll just be a lot easier than writing this beautiful mess. I think the answer is negative 9 plus 12 is 3, so 8100. Check it on your calculator. Let me know if that's right while I write this down.
Sam, you know the
8,100.
final answer for I, how would you put it in? Like, how many
Final
decimals?
answer? Wait, what?
For the one we're doing now, how many decimals would you put for your final answer?
Oh, look, rule of thumb for worldwide is if you don't want to get anything wrong, you usually go to 4 decimal places.
Okay, 4 decimal places.
So the industry standard for mathematics and statistics is 4 decimal places.
Okay, beauty.
The idea is if you're going to 4 decimal places, usually we use things in 2 decimal places. So if you've gone to the 4th, that shouldn't affect your 3rd decimal place, which would not affect your 2nd decimal place. That's kind of the idea. But anyways, 4
Yeah.
decimal places is the idea. All right, cool. Lissandro, tell me.
Yeah. Now you log both sides.
Log. And
divide by 0.1.
too easy. See how I said 100% will be in your exam? You guys can see. They can change the words slightly, but the math has always been the same. Log 8100 from, again, if you want to look, 1990s, right? 1990s to 2011 to 2020 to 2021. It won't change. It's math. It cannot change. Log 8100 divided by 0.1. L equals 89.9962. So the maximum loudness can be 89.99.
Yeah, perfect. I got up to that stage and I'm like, I don't know what the hell to put.
And triple A. Last one. By how much will the loudness of a sound have increased if its intensity has doubled? Okay. If this doubles, how much will the loudness of a sound have increased? That's worth 2 marks. So all it's saying is that the intensity now, instead of it being 8.1 times 10 to the power of negative 9, it is 2 times 8.1 times 10 to the power of negative 9. Divide by 10 to the negative 12. You shall get 16,200. Log both sides. Come on, guys. It's simple now, isn't it? Log 16,200 equals 0.1 L. Then you know you're going to divide by 0.1. But the thing is, that's not the answer. The reason why they made you do that again, it's not so that you can work out 96.927. It's so that you can answer this bit, and that's why it's worth 2 marks. By how much has it increased? And that's what most students miss. It's increased by 96.927 minus 89.99. So by you doubling, it has increased by 6.9315 decibels or whatever it was. Loudness. Yeah, decibels. And it was back in 2008 when they started introducing more and more of these styles of questions. By how much? How long will it take for the chicken to cook? You'll see a lot of these styles of questions. They're all the same. If you actually just find the time, and imagine you found time is 45 minutes, let's say, you will not get full marks because the question said, how long will the chicken take to cook? You have to actually write, the chicken will take 45 minutes to cook. So same thing, by how much will the loudness have increased? I actually wrote it's increased by 6.9315 decibels. If you don't write it's increased by, you just write 6.9315, you actually, from 2008 onwards, they decided no more. We're not going to give marks because you're not actually answering the question. You have to answer the question.
Hey, Sam.
Yes.
When I put in that equation 2 times 8 times 10 to the power of negative 9.
10 to the power of negative 9 over 10 to the power of negative 12. Yep.
Yeah, when I put that whole equation in without the log, it gives me 16,000. And I put it in like... Let me just do it one more time.
No, because you just told me 2 times 8. It's 2 times 8.1.
Oh, I didn't... Okay, never mind. I'm blind.
All good. It's easy. All I did, just so you know, I just doubled this number. 8100. I just times it by 2. 16,200. But it should work out. It should still give you 16,200. Okay. Let's do another one. Last one, I guess. Is actually the last one? Yeah, pretty much the last one. 2-unit HSC from 1990. Just before you guys were born. Alright, it is assumed that the number NT, number of termites, in a certain amount at time is greater than 0 is given by this. This is your equation this time, so a little bit different. They're using it as a fraction. A is a constant and T is measured in months. A is a constant, T is measured in months. I, at time T is 0, N of T is estimated at 3 times 10 to the power of 5 termites. What is the value of A? Okay, who wants to give it a shot? What am I going to write for I? It's not hard. Time is 0, N of T is this. What is the value of a? There's your function. What are you going to write?
N bracket 0.
Say again. And technically, you're not wrong. Yeah, n of 0 because t is 0, but you don't need to. You're right. So don't think that's wrong. A you're going to still have there, Eden, and then you'll have 2 plus e to the power of what? When you just said n of 0.
0.
E to the power of 0. And what does nt equal to?
0?
Oh,
Oh, 3 times 10, 5.
yeah. And then what's the value of a? What's e to the 0? 1. 1 plus 2.
Yeah.
3. 3, you multiply, you're done. That's it. That was easy, wasn't it?
Yes.
Right. What is the value of nt? This time you're solving for this after 1 month. A is this number, which looks like, what, 900,000? So A is 900,000. Whoa, too much. What am I doing? 900,000 over 2 plus, it says after 1 month, and t is in months. So e to the negative 1. Plug that into your calculator. E negative 1. After 1 month, you will have 380,086.92. So you'll pretty much have 380,087 termites. Triple I. How many termites would you expect to find in a mound when T is very large? What does that mean? When T is very large. What do you think they're trying to tell you? T is what? Very large.
The number of termites.
Yeah, you are. We will work out the number of termites. But when T is very large, what does that mean for T? What does T equal to?
Is it just t equals greater than 1?
Oh, now, very large. When T is very large. You're thinking about very large. Like, what's the things I know about very large? Say it again?
Infinity?
Beautiful. This is why you got to keep guessing. T equals infinity. So it's saying what happens as T becomes infinity. Well, let's have a look. A is 900,000. 900,000 over 2 plus e negative infinity. Okay, what happened as to the exponential as you approach negative infinity?
It gets closer to 0.
Good job. And then 0 plus 2?
2.
Over 2. So what happens to the number of termites? As it gets very large, it gets close to 450,000. So pretty much, it's saying the maximum termites you'll have, according to this modeling, is 450,000 termites as T approaches infinity. So if it's 20 months, 50 months, a million months, it doesn't matter. The maximum you'll ever have is 450,000 termites. And that's how that infinity works. So when T is approaching infinity, or if T is very large, it always means infinity. If we ever say it's very small, we always mean, well, if we say small, yeah, small means 0. So small does not mean negative infinity. Small means 0. If you want negative infinity, you would actually probably say negative large numbers or something like that. So small is not negative infinity. Be careful with that. Small is 0. But anyways, 99.99% of your questions are always about t's approaching infinity. So as t approaches infinity or t becomes infinity, this exponential function approaches 0, which means your whole number of termites approaches 450,000 termites. And that would be the maximum that you could get at any one time. All right. Any questions? Okay. Let's go on. Let's go on and see. I've left a few for you guys to work on at your own time. Just closed. Great. Where are we?
So
Yeah.
very large is always infinity, right? Just
Very large is always infinity.
okay.
Yep. I'll try to get another one else. I just want to see. I'll pause the recording because I'm pretty happy.